March 2, 1973. Bailey Crossroads, Virginia. Construction is underway on the Skyline Plaza apartment complex, a high-rise development rising in the suburbs outside Washington, D.C. on this morning. One apartment building within the complex, identified as Building A4, collapses along with its adjoining parking garage. The structure is a reinforced concrete flat slab building, still under construction at the time of failure. 14 construction workers are killed. 34 others are injured. This is not a finished building undone by age or neglect. It is a building that failed while it was still being built, floor by floor, on a schedule, with workers present inside it, and beneath it at the moment, concrete and formwork gave way. The scale of the loss placed Skyline Plaza among the deadliest construction failures in American history, and its cause did not stay a mystery for long. Investigators would trace the collapse to a specific sequence of decisions made in the days and hours before the concrete failed. This was a flat slab structure, a type of design where floor slabs are supported directly by columns without the intermediate beams found in other systems. That kind of design places enormous reliance on each slab reaching sufficient strength before the loads of construction above it are allowed to bear down. What happened at Skyline Plaza did not begin with an unforeseeable act of nature or a hidden flaw buried in the original design. It began with the ordinary pressures of a construction project in progress, and with choices made about how fast the work could move. What follows is the documented chain of technical decisions that led to the failure, the institutional gaps that allowed it, and the human toll that resulted, drawn from the official investigation into the collapse. In the aftermath of the collapse, the National Bureau of Standards, known today as NIST, was called to the site 3 days after the building came down. Their investigation focused on the physical mechanics of the failure. What gave way first, and why? The NBS concluded that the most probable cause was a punching shear failure of the 23rd floor slab. Punching shear failure, in a flat slab structure, is a specific and violent mode of failure in which a column effectively punches through the surrounding slab, because the slab cannot resist the concentrated load transferred at that connection point. Once that failure initiates at one location, it can propagate, and in this case, it brought down not just the 23rd floor slab, but everything above and below it that depended on that connection, including the adjoining parking garage. But a punching shear failure does not happen in a properly cured, properly supported slab under normal conditions. The investigators identified 2 specific contributing factors that explain why this slab failed when it did. First, the shores, the temporary vertical supports holding up the slab during construction while the concrete gained strength, had been removed prematurely from beneath the 23rd floor slab. Second, the concrete in that same area of the 23rd floor slab, the concrete that was supporting the weight of the 24th floor being built above it, had not yet reached adequate strength to carry that load on its own. These 2 factors compound each other directly. Shoring exists specifically to carry the load of upper floors, while lower floor concrete is still curring and gaining strength. Removing that shoring early only becomes catastrophic if the concrete underneath has not yet reached the strength needed to stand on its own. At Skyline Plaza, both conditions were present at the same time, on the same slab, at the same point in the building's vertical sequence of construction. The concrete was not ready. The supports meant to compensate for that were already gone. The load from the floor being built above had nowhere to go but into a slab that could not take it. And the result was the punching shear failure that brought down Building A4 and its parking garage. The physical mechanism of the collapse, premature shore removal combined with immature concrete, raises an obvious question. Why would shores be removed before the concrete supporting the floor above was ready to carry that load? The investigation's findings point directly at process, not just materials. Investigators found noncompliance with OSHA construction standards in multiple specific areas: formwork, field-cured concrete test specimens, and crane installation. Most directly relevant to the collapse itself, the procedures used for removing the supporting forms did not comply with applicable standards. This is the crux of the failure from a process standpoint. Concrete strength on a construction site is not something you assume, it is something you test. Field-cured test specimens exist precisely so that crews can verify, on-site, using samples cured under the same conditions as the actual structure. whether concrete has reached the strength required before the next stage of construction proceeds, including before shores are pulled. When the procedures for that testing and for the removal of formwork do not comply with applicable standards, the decision to strip shores from beneath a slab stops being a verified engineering judgment and becomes a schedule-driven assumption. On a multi-story building under construction, every floor's slab curing time represents time the project is not moving forward to the next level. Shoring is expensive to leave in place and reuse further up the building. It ties up materials and labor that a project wants moving upward, not idle beneath a curing slab. The pressure to strip forms and shores as soon as reasonably possible so they can be repositioned for the next floor is a constant and ordinary feature of concrete high-rise construction. Skyline Plaza's investigation does not describe a single dramatic act of negligence. It describes a documented gap between what applicable standards required for verifying concrete strength and formwork removal and what procedures were actually followed on site. That gap is where schedule pressure and cost of idle shoring equipment meet the physical reality of curing concrete. And at Skyline Plaza, that gap produced a slab that was asked to carry a load it was not yet strong enough to bear, with the safety margin of its shoring already removed. 14 construction workers died at Skyline Plaza. 34 more were injured. These were not people encountering a finished structure with a hidden flaw. They were the workforce actively building the structure at the moment its 23rd floor slab failed under a load it could not support. In a flat slab high-rise under construction, workers are present at multiple levels simultaneously. Pouring and finishing concrete on upper floors, moving materials, operating equipment, present in and around the very formwork and shoring systems whose removal procedures the investigation would later find did not comply with applicable standards. When a punching shear failure initiates and propagates through a slab, the collapse is not contained to a single floor. Building A4 came down along with its adjoining parking garage, meaning the failure's physical reach extended across more of the structure than the single slab where it began. The workers killed and injured that day were positioned within a structure whose vertical sequence of construction, curing, shore removal, and reloading was, according to the subsequent investigation, not following the procedures the applicable standards required. There is no fact in the record suggesting these workers had any way to know that the concrete beneath their feet or above their heads had not yet reached adequate strength, or that the shoring meant to compensate for that had already been stripped away. The gap between documented procedure and required standard was not visible to the people whose safety depended on it. In the aftermath, the scale of casualties, 14 dead and 34 injured from a single collapse during ordinary construction activity, made Skyline Plaza one of the most significant construction failures in the country's history, not because of the complexity of what went wrong, but because of how many people were exposed to a preventable sequence of decisions at once. The collapse did not discriminate between trades or crews. It took down whoever was present in Building A4 and its parking garage at 3 a.m. on March 2, 1973, when the 23rd floor slab gave way beneath and above them. That toll is the direct, measured human cost of the compounding failure identified by the National Bureau of Standards. Shores removed before their time, and concrete asked to carry weight it was not yet strong enough to bear. The investigation into Skyline Plaza did not end with an assignment of a single cause in isolation. It documented a chain, a punching shear failure at the 23rd floor slab, caused by the combination of prematurely removed shoring and concrete that had not reached adequate strength, occurring alongside documented noncompliance with OSHA standards covering formwork, field-cured concrete test specimens, and crane installation, and specifically non-compliant procedures for removing supporting forms. Each piece of that chain reinforces the others. The collapse became, in the decades that followed, a standard case study in American engineering education, specifically on the subjects of formwork and shoring safety. It has been cited for decades in teaching material produced by the American Society of Civil Engineers and by NIST, the successor institution to the National Bureau of Standards that investigated the collapse in the first place. That its lessons are still taught today, in the specific areas of formwork and shoring, tells you where the profession itself located the core failure. not in the concrete mix, not in the original structural design of the flat slab system, but in the site procedures governing when supports could be removed and whether concrete strength had actually been verified before the next load was placed on it. Skyline Plaza stands as a documented case of what happens when the procedures meant to verify readiness, curing time, tested strength, compliant shore removal, are not followed with the same rigor as the schedule that depends on them moving forward. 14 workers did not return home because a slab was asked to do a job it was not yet ready to do, and the supports that could have compensated for that were already gone. There is no dramatic villain named in the investigation's findings, no single act of sabotage or singular reckless individual. There is a documented gap between applicable standards and actual procedure, on a job site building upward, floor by floor, under the ordinary pressures of a construction schedule. That gap is what the National Bureau of Standards identified in 1973, and it is what engineering students have studied in ASCE and NIST material in the decades since. Skyline Plaza remains, in the historical record, a case where the sequence of decisions, not a single catastrophic error, produced a collapse that took 14 lives and injured 34 more. And it remains a fixed reference point for why formwork and shoring procedures are treated, in engineering education, as matters of life and death rather than matters of scheduling convenience.